ಫ್ರೆಂಡ್ಸ್, ಗುಡ್ ಮಾರ್ನಿಂಗ್. ನಾನು ನಿಮ್ಮ ಮೋಹನ್ ಸರ್ ಮಾತಾಡ್ತಿರೋದು. ಸೊ ಟುಡೇ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ನೀಟ್ ಕ್ರ್ಯಾಶ್ ಕೋರ್ಸ್ ಆನ್ ಜನರಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ, ದಟ್ ಈಸ್ ಕ್ಲಾಸ್ 11th. ಸೊ ಫಸ್ಟ್, ನೀಟ್ ಕ್ರ್ಯಾಶ್ ಕೋರ್ಸ್. That is, the chapter is General Organic Chemistry. So we'll divide the general organic chemistry in three parts. So in first part, so we'll discuss about bond fusions, bond fusion, and reaction intermediates. In second part, we'll discuss about electronic effects. Then later we'll discuss about isomerism, followed by qualitative and quantitative analysis. So first I'll discuss bond fusion. So let us see, bond fusion means bond cleavage. So in chemical reaction, there is a breaking and making of bond. So new bonds are formed and old bonds are broken. ಸೊ ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ರಿಯೇಜೆಂಟ್ಸಲ್ಲಿ ಬಾಂಡ್ಸು ಬ್ರೇಕ್ ಆಗಬೇಕು ಮತ್ತು ಬಾಂಡ್ಸ್ ಫಾರ್ಮ್ ಆಗಬೇಕು. ಸೊ ಬಾಂಡ್ ಬ್ರೇಕಿಂಗಲ್ಲಿ ಟೂ ಟೈಪ್ಸ್ ಇದೆ. ದ ಫಸ್ಟ್ ಟೈಪ್ ಈಸ್ ಕಾಲ್ಡ್ ಹೋಮೋಲೈಟಿಕ್ ಬಾಂಡ್ ಫ್ಯೂಷನ್. ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆ್ಯಸ್ ಸಿಮೆಟ್ರಿಕಲ್ ಬಾಂಡ್ ಫ್ಯೂಷನ್ ಅಂತಲೂ ಕರೀತಾರೆ. ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ heterolytic bond fusion, or it is also called as unsymmetrical bond fusion. So we'll discuss one by one. First I'll take homolytic bond fusion. The first one is homolytic bond fusion. So in homolytic bond fusion, let us take an example. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Let us consider a molecule AB, and there is a single bond between A and B. See here, ಇಲ್ಲಿ ಮಾಲಿಕ್ಯೂಲ್ ಮಧ್ಯೆ ಎ ಮತ್ತು ಬಿ ಮಧ್ಯೆ ಒಂದು ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದೆ. ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆದಾಗ ಹೋಮೋಲಿಟಿಕ್ ಬಾಂಡ್ ಕ್ಲೀವೇಜಲ್ಲಿ ಹೇಗಾಗುತ್ತೆ ಅಂದರೆ, ಆಫ್ಟರ್ ಬ್ರೇಕಿಂಗ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಸಪರೇಟ್ ಆಗುತ್ತೆ. ವೈಲ್ ಸಪರೇಟಿಂಗ್, ಈಚ್ ಸಪರೇಟಿಂಗ್ ಆಟಮ್ ಕ್ಯಾರೀಸ್ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ದಟ್ ಈಸ್, ಆಫ್ಟರ್ ಸಪರೇಟಿಂಗ್ you'll get that is A dot plus B dot, and these resultant products are called free radicals. These are odd number electron species. ಸೊ ಈ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ಸನ್ನು ಇನ್ ಡೀಟೇಲಾಗಿ ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ ರಿಯಾಕ್ಷನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ಸಲ್ಲಿ. ಸೊ ಇದು ಹೋಮೋಲಿಟಿಕ್ ಬಾಂಡ್ ಫ್ಯೂಷನ್. ಸೊ ಸಪ್ರೇಟಿಂಗ್ ಆಟಮ್ಸ್ ನೋಡಿ, ಎ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತೊಗೊಂಡಿದೆ, ಬಿನೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತೊಗೊಂಡಿದೆ. ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಹೆಟಿರೋಲೈಟಿಕ್ ಬಾಂಡ್ ಫ್ಯೂಷನ್. ಸೊ ಹೆಟ್ರೋಲೈಟಿಕ್ ಬಾಂಡ್ ಫ್ಯೂಷನಲ್ಲಿ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ನೋಡಿ, ಸೇಮ್ ಮಾಲಿಕ್ಯೂಲೇ ತಗೊಳ್ಳೋಣ. ಸೊ ದಟ್ ಈಸ್ A to B. Here bond fusion ಹೆಂಗಾಗುತ್ತೆ ಅಂದರೆ based upon the electronegativity of the bonded atoms. So let us consider the electronegativity of B is greater than A. Electronegativity of B is greater than A ಆದರೆ here while separating B carries both the electrons. B carries both the electron. So then A gets positive charge, B gets negative charge. ನೋಡಿ ಎರಡೂ ಎಲೆಕ್ಟ್ರಾನು ಬಿಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆದಾಗ here 2 electron means 1 electron is from A, 1 electron is from B. So while separating, the electronegativity of B is greater than A, since hence both the electrons are transferred to B. So B gets negative charge, A gets positive. So there is decrease in electron density on A, hence it will get a positive charge. There is increase in electron density on B, hence B gets a negative charge. So here the positively charged species is called the positively charged species A. It is called electrophile, and B is called nucleophile. Nucleophile. Similarly, let us consider A, B. If electronegativity of A is greater than B, then while separating A gets both the electrons. So then A will get negative charge, B will get positive charge. So here A minus is called electrophile. Sorry. A is nucleophile and the B is electrophile. So here free radicals, electrophiles and the nucleophiles, these are called reaction intermediates. These are called what? Reaction intermediates. Same reaction intermediates andre reaction intermediates means they are formed during the reaction and they lost at the end of the reaction. So reaction ಆಗಬೇಕಾದ್ರೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗೋತ್ತಿಗೆ ದೇ ಬಿಕಮ್ ಲಾಸ್ಟ್. ಸೊ ಅದರಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ಸಲ್ಲಿ ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ಸ್, ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಯಾವುದ್ಯಾವುದಪ್ಪ ಅಂದರೆ, ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಈಸ್ free radicals, then carbocations, then carb anions, then electrophiles. Before that we'll take carbene, then after that electrophiles, then nucleophiles. So we'll discuss one by one. First we'll take free radicals. So as we know that so free radicals are formed by the homolytic bond fission. So I'll write some important SIPs, some important points regarding free radicals. So the first point is they are formed due to homolytic bond cleavage, bond fission, homolytic bond fission. And here the carbon atom having one odd electron, carbon atom has one odd electron. Since free radicals are odd electron species, so that is they are having incomplete octet. So due to incomplete octet, they are highly reactive, and next point is, so in free radicals, the carbon atom undergoes sp2 hybridization. It undergoes a sp2 hybridization. So sp2 hybridization means here carbon to hydrogen carbon bond angle is 120 degree, and the shape of the free radicals is planar triangle. These are all very important points regarding your NEET point of view. So let us consider some important free radicals. So and along with that we'll see the stability also. Some examples, I'll give some examples of free radicals along with their stability order. So that is, the first one is the most stable free radical is benzyl free radical. This is called benzyl free radical, which is more stable than allylic free radical, which is more stable than tertiary free radical, CH3 CH3 free radical, which is more stable than CH3 CH3 dot. So this is secondary free radical, which is more stable than CH3 CH2 free radical, which is more stable than methyl free radical. So that is CH3 free radical. So this is allyl free radical, this is tertiary free radical, this is secondary free radical, this is primary free radical, and this is what a methyl free radical. So this is the stability order of some free radicals. So once again I'll discuss. So that is, free radicals are formed due to what? A homolytic bond fission. And here the carbon atom carries odd electron, hence free radicals are odd electron species. So odd electron means they does not contain 8 electrons in their octet. So due to incomplete octet, they are highly reactive. To attain octet configuration, their reactivity is very high with other free radicals. In free radicals, the carbon atom undergoes what? Very important is it undergoes sp2 hybridization. So and the bond angle is 120 degree and the shape is a planar triangle. So this is regarding free radical. So next we'll discuss about carbocation. The second intermediate is carbocation. Carbocations, and these are the ions in which carbon carries a positive charge, and these carbocations are formed due to heterolytic bond cleavage, heterolytic bond fission. And very important point is here, carbon atom carries a positive charge. So another important point is, again, here carbon carries positive charge means there is incomplete octet. So due to incomplete octet, highly reactive towards electron rich species. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಆ ಕಡೆಗೆ ಇದ್ರದ್ದು ರಿಯಾಕ್ಟಿವಿಟಿ ಜಾಸ್ತಿ ಇರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ಹಿಯರ್ carbon atom, very important point. Carbon atom undergoes sp2 hybridization, same sp2 hybridization, and here also the bond angle is 120 degree, and shape is planar triangle. So this is regarding the very important some important points of what carbocation. Now let us see some examples of carbocation. So same like ನೋಡಿ, regarding examples and stability order ನೋಡಿದ್ರೆ there is no difference between carbocation and free radicals. So carbocation ಏನು stability order ಇದೆ, the same stability order is for carbocations. So that is we'll take first one is benzyl carbocation, CH2 plus, and second one is allylic carbocation, CH2 plus, which is more stable than tertiary carbocation, which is more stable than secondary carbocation, which is more stable than primary carbocation, which is more stable than methyl carbocation. So this is benzyl carbocation, this is allylic carbocation, this is tertiary carbocation, this is secondary carbocation, this is primary carbocation, this is methyl carbocation. So this is regarding what carbocations and free radicals. So next important is third one, carb anions. Third one is carb anions. These are the ions in which carbon carries a negative charge. Here also let us see some important points. They are formed by carb anions are formed by the heterolytic bond cleavage, heterolytic bond fission, and here carbon carries negative charge, that is a pair of electrons, one negative charge means two electrons, a pair of electrons available 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 on carbon atom. Then here carbon atom undergoes sp3 hybridization, very important, sp3 hybridization. ಸೊ sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇದೆ ಅಂತಂದರೆ ಡೋಂಟ್ ಥಿಂಕ್ ದಟ್ ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಶೇಪ್ ಇದೆ ಅಂತ ಅಂದ್ಕೋಬೇಡಿ. ಸೊ ಇಟ್ ಈಸ್ ಸಿಮಿಲರ್ ಟು ಲೈಕ್ ಅಮೋನಿಯಾ. ಸೊ ಅಮೋನಿಯಾ ಯಾವ ಶೇಪ್ ಇರ್ತದೆ? ಶೇಪ್ ಈಸ್ ಪಿರಮಿಡಲ್ ಶೇಪ್ ಇರ್ತದೆ, ಏಕೆಂದರೆ ಒನ್ ಆಫ್ ದಿ ಆರ್ಬಿಟಲ್ ಕಂಟೈನ್ಸ್ ಎ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಬಾಂಡ್ ಪೇರ್ ಇರಲ್ಲ, ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತದೆ. ಸೊ ಇಟ್ ಈಸ್ ಸಿಮಿಲರ್ ಟು ಲೈಕ್ ಅಮೋನಿಯಾ, ಪಿರಮಿಡಲ್ ಶೇಪ್ ಇರ್ತದೆ. ಸೊ ನೆಕ್ಸ್ಟ್, ಆ್ಯಂಡ್ ದ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಇಟ್ ಈಸ್ ಆಲ್ಮೋಸ್ಟ್ ನಿಯರ್ ಟು 107 degree. Right. So this is regarding carbanions. Now let us see some examples. So some examples and the stability order. Except benzyl carbanion, it is exactly reverse of carbocations. Stability order ಆಗಲಿ ಮತ್ತು ಎಕ್ಸಾಂಪಲ್ಸು ಇಲ್ಲೂ ಅಷ್ಟೇ. ಬೆನ್ಸಿಲ್ ಕಾರ್ಬ್ಯಾನಯೋನ್ ಏನಿದೆ, ಇಟ್ ಈಸ್ more stable. This is ಬೆನ್ಸಿಲ್ ಕಾರ್ಬ್ಯಾನಯೋನ್. ನೆಕ್ಸ್ಟ್ ಇದರಲ್ಲಿ ರಿವರ್ಸ್ ಆಫ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್ಸ್ ಆ್ಯಂಡ್ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ಸ್. ಅಲ್ಲಿ ಮೀಥೈಲ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಆಗಲಿ ಮಿಥೈಲ್ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ ಆಗಲಿ ಏನಿತ್ತು, ದೇ ಆರ್ ಲೀಸ್ಟ್ ಸ್ಟೇಬಲ್ ಇತ್ತು. ಮಿಥೈಲ್ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಮಿಥೈಲ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್. ಬಟ್ ಮಿಥೈಲ್ ಕಾರ್ಬ್ಯಾನಯೋನ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ primary carbanion, which is more stable than secondary carbanion, which is more stable than tertiary carbanion. So this is regarding what stability and the examples. This is methyl carbanion, this is primary carbanion, secondary carbanion and tertiary carbanion. So this is regarding carbanion. Now let us move on to carbenes. The fourth one is carbenes. ಸೊ ನಿಮ್ಮ ಈ ಸಿಲೆಬಸ್ಸಲ್ಲಿ ಕಾರ್ಬಿನ್ಸ್ ಬಗ್ಗೆ ಅಂದರೆ ಕಾರ್ಬಿನ್ಸ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ಸ್ ಆಗುವಂಥ ವೆರಿ ಫ್ಯೂ ರಿಯಾಕ್ಷನ್ಸ್ ಇದೆ, ಅದು ಸೆಕೆಂಡ್ ಇಯರಲ್ಲಿ ಬರುತ್ತದೆ. ಸೊ ಕಾರ್ಬಿನ್ಸ್ ಬಗ್ಗೆ ಲೆಟ್ ಅಸ್ ಸಿ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಸ್. SIPs ನೋಡೋಣ. So that is SIP. The first point is these are formed by the photolysis. Photolysis means presence of light. Photolysis of either diazomethane or ketene. So that is CH2 double bond N single bond N minus plus This is called diazomethane in presence of light. Bond breaking takes place in presence of light, then it is called photolysis. You'll get CH2 dot with the liberation of N2 gas. ಹೆಂಗೆ ನೋಡಿ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿನ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನೆಕ್ಸ್ಟ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಕಂಪ್ಲೀಟಾಗಿ ಇದೇನಾಗುತ್ತೆ, ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಸೊ ಅವಾಗ CH2 dot. So here this is called carbene. Here the valence shell of carbon contains 6 electrons. The liberation of water, nitrogen gas. Similarly, this can also be prepared by using photolysis of ketene, CH2 double bond C double bond O. So that is when here also the bond cleavage takes place. Here one electron comes here, another electron comes here, here one electron, here one electron. So hence this bond gets broken and get CH2 dot plus carbon monoxide gas. This is also what? Carbene. Here also ನೋಡಿ, ಈ ಕಾರ್ಬೀನ್ಸ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ contains how many electrons in their valence shell? 6 electrons. Again there is no 8 electrons in octet configuration ಇಲ್ಲ. So incomplete octet ಇರೋದ್ರಿಂದ, so due to incomplete octet they are highly reactive. So this is regarding what? Carbenes. So again, in carbenes there are two types of carbenes. So one is singlet carbene, so another one is triplet carbene. So singlet carbene, triplet carbene. So singlet, we'll see this singlet carbene is here. These electrons are unshared electrons. These electrons are what? Unshared electrons. Here these electrons are unshared. Based on that, unshared electrons are paired. ಇಲ್ಲಿ unshared electrons pair ಆಗಿರುತ್ತೆ. ಸೊ ಹೆಂಗೆ, here carbon H, it is H. Here the orbital contains these unshared electrons. Similarly here unshared electrons are not paired. So ಹೆಂಗಿರ್ತದೆ, here H carbon H, these are all p orbitals. So this p orbital, here there is one electron, here there is one electron. So in singlet carbene the electrons are paired, in triplet carbene electrons are unpaired. So that is, and the next point is here the bond angle between what? H carbon H bond angle is 103 degree. Here the bond angle of H CH is 180 degree. 180 degree. Here due to paired, here in singlet carbene the electrons are paired, hence it is diamagnetic. The magnetic property is diamagnetic. Here the electrons are unpaired, hence it is paramagnetic. Then if you compare the stability of singlet carbene and triplet carbene, singlet carbene is less stable and triplet carbene is more stable. Here if you see the shape, it is having bent shape, here it is having linear shape. Linear shape. So this is regarding what? Carbenes. So next we left with the two intermediates. So that is nucleophiles and electrophiles. First we'll see the electrophiles. Electrophiles, the name itself indicate electro means electron, phile means liking, so that is they are electron deficient species. They are electron deficient species and they are also called as Lewis acids ಅಂತಲೂ ಕರೀತಾರೆ. Why they are also called as Lewis acids? Because they have tendency to accept the electrons donated by electron rich species, hence they are called Lewis acids. So in electrophiles there are two types. One is positively charged electrophiles ಇದೆ, then neutral electrophiles ಇದೆ. Neutral electrophiles. So positively charged electrophiles ಅಂತಂದರೆ she'll get chloronium ion, bromonium ion, I plus, H plus, R plus, NO2 plus, NO plus, etc. All positively charged species are called electrophiles. If you take the neutral electrophiles, that is AlCl3, FeBr3, SO3, boron trifluoride, BCl2, etc. These are all what? Neutral electrophiles, that they are electron deficient species. So on the next one is fifth one, that is sixth one, nucleophiles. Nucleophiles. So nucleophiles means the name itself indicate nucleo means nucleus, philes means liking. Nucleus liking species means they like a positive charge. Positive charge like ಮಾಡುತ್ತೆ ಅಂದರೆ they are electron rich species. They are what? Electron rich species. Electron rich species, and they are called Lewis bases because since they are electron rich, they have capacity to donate electrons. So like electrophiles, how they are classified positive and neutral, similarly nucleophile also having negatively charged nucleophiles and neutral nucleophiles. So negatively charged nucleophiles, that is chloride Cl minus, Br minus, I minus, Cn minus, OH minus, H minus, etc. All negatively charged species are called what? Nucleophiles. The next one is Other examples for neutral nucleophiles, so that is NH3 and water, since they contains see ammonia. In ammonia, nitrogen carries a lone pair of electron. In water, oxygen carries lone pair of electrons. You can take alcohols. In alcohols, oxygen carries lone pair electrons. So they, if a molecule contains lone pair means they have tendency to donate a electron. ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ ಅಂದರೆ ಆ ಮಾಲಿಕ್ಯೂಲ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟ್ ಮಾಡೋ ಕೆಪಾಸಿಟಿ ಇರ್ತದೆ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಡೋನರ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಲೆವಿಸ್ ಸ್ಪೇಸಸ್. ಸಿನ್ಸ್ ವೈ ದೇ ಆರ್ ಡೊನೇಟಿಂಗ್, ದೇ ಆರ್ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಚ್ ಸ್ಪೀಷೀಸ್. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಅಮೈನ್ಸ್. ಸೊ ಅಮೈನ್ಸಲ್ಲಿ ಕ್ಯಾನ್ ಟೇಕ್ ಆಲ್ ಟೈಪ್ಸ್ ಆಫ್ ಅಮೈನ್ಸ್. ಪ್ರೈಮರಿ ಅಮೈನ್ಸ್ R2NH, secondary amine R3N, tertiary amine H2S, etc. These are all example for what? Neutral nucleophiles. Here it is primary amine, it is primary amine, it is secondary amine, this is tertiary amine. These are the derivatives of ammonia. All amines are example for nucleophiles, and all nucleophiles are called Lewis bases. So this is regarding part 1. See, you go through once in detail, make a notes, we'll discuss in detail. Next part ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಫೆಕ್ಟ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಫೆಕ್ಟ್ಸು ರಿಗಾರ್ಡಿಂಗ್ ನೀಟ್. ಸೊ ಇಷ್ಟು ನಿಮಗೆ ವೆರಿ ಬೇಸಿಕ್ಸ್ ಬೇಕಾಗಿರೋವಂಥದ್ದು. ಸೊ ಥ್ಯಾಂಕ್ ಯು.